did work. All right, let me grab this coffee and then we'll get started.
What if it's just us four?
And we'll have class.
Well, yeah, I'm saying it's us four today.
Well, then they will have to watch the recording.
Okay.
That's how that goes.
I think you should get bonus points for being making commitments of boosters.
No, that's not the idea.
Oh, come on.
If anybody should get bonus points, it should be them if they actually do watch the recording and do the class. Speaking of them, there's another one. We found him. We found him. All right, we're on 3-2. Does that sound accurate? Systems of inequalities by graphing, which means we're going to need the tablet and the television. Let's see. I think I got a paper to give to you. Doesn't have a name on it, but I think this is yours. I think it is. I thinketh so. All right. Grab some things. All right. Sounds good. Okay. Okay. Hello, machine. What you do? Why are you sitting there like a goober? Try again. Different buttons. Oh, it's because it's unplugged. Who could have done that? It was me, guys. Don't worry. I did it. There it goes. Okay. Let's grab a picture of your stuff. What numbers did we do? 2 through 24. Evens. We didn't do all. You're lying. All right. No, not my face. Try again. Boom, boom, boom. Oh, did I accidentally turn it off? Stupid delayed reaction buttons. Oh, this says I didn't. But now it's just sitting there like a goober. Oh, just kidding. Maybe we're in luck. We are, in fact, in luck. Great. Number 2. Number 2 doesn't have a picture. What is number 2? Let's see. Oh, did I go back too far? That would be annoying. I did. That's crazy. This green looks like that yellow, apparently. Number 2. Oh, it's because it's in the margin. We found it.
We found it.
There we go. Oh, there we go. Good enough for government work. All right, number 2 looks like that. So to be clear, the way they do it is they shade both. So it's really this darkest region that we're shading. That pie piece right there. Okay. Number 4. A is in the answer appendix. It's probably in this picture. Number 4A is right there. And 4B is right there. Hot dogs. Hot dog, hot dog, hot diggity dog. Number 6 is that one. Yes, it is. Number 8 is that one. Again, it's the darker region that is the shaded region. That's just how the book does it. Number 10 is right there. It's the top right corner piece, right? Number 12 is that guy. Number 14 is that one. Yes, it is. That's correct. Yes, it is. Number 16 is that one. Number 18 is 0, 2, 4, 0, and 0, 0. Number 20 is 1, 9, 4, 0, 4, 9. 22 is negative 6, negative 5, negative 2, 4, 5, 7, 5, and negative 2. What am I saying? 7.5, negative 2. What questions do we have?
Can you do 6?
We can do 6. Yes, we can. Number 6 says, find the coordinates of the vertices of the triangle formed by each system of inequalities. All right, sounds great. Did I read 6? I didn't read the answer to 6.
It's a picture.
No. It's funny because it doesn't actually even ask you to graph it. But it will make a picture, so let's do it. All right, so we've got some inequalities here. 3y greater than or equal to negative 7x minus 16, 7y less than or equal to x plus 32, and y greater than or equal to 15x minus 40. Right? So, we solve this by graphing. We stick it in there, we put all the things on there and whatever else. That's great. Now, I'd ask specific points in where they cross, right? So, for that part, if we want an exact answer, we don't want to guess, then we don't really even want to do that with graphing, right? We want to do that by hand. We want to pretend like these are equals and solve a system using whatever method we want to use. So what method do you want to use? Substitution or elimination? Somebody's got to give an answer. We're going to be stuck here forever. Substitution sounds fine. Let's go ahead and solve them all for y, because we do that if we're graphing anyway, right? So if we're going to solve this for y, what would we do? Divide by 3 sounds great to me. Divide this by 3, and this by 3, and this by 3. So y is greater than or equal to. We don't care about the greater than or equal to. We're going to pretend like it's just equal to and solve it by substitution here in a second. What about this one? How would we solve this one for y? Divide by 7. Y'all are sounding like my geometry class today. Why are y'all all asleep? Wake up. Come back to life. Great. Now you're in math class. Wake up. Life has consequences. If you choose to stay up playing games, fine, but you're going to have to somehow make it work the next day. It's part of learning to adult, right? That's a difficult thing to learn how to do, I know. Trust me, I've been trying to learn it for years. All right. So let's give these some names so we can kind of label them down there. Let's call this equation A, and this equation B, and this equation C. That way I can say, yeah, it's easier for me to say words and you understand what I mean, right? Okay, so let's solve the system AB. So if we're solving that with substitution, what are we going to do? Somebody in here made a decent grade on the quiz the other day. A few of you did, right? What do we got to do to solve that using substitution?
Solve one for x.
Why would we have to solve one for x? We've already solved them for y.
Plug one in for y.
Plug one in for y. Sounds great. I love that idea. Let's do it. So since these both equal y, we can take and substitute this one into y right there. Yay, yippee skippy. So I'm just going to replace this with an equals, right? Negative 7 over 3x minus 16 thirds equals x over 7 plus 32 sevenths. Let's practice a skill that's going to be useful repeatedly in this class, especially once we start chucking letters in the denominator. But first thing first, I'm the realist. Drop back and let the whole world feel it. But first, what we should really do is kill those fractions. I'm a little bit disappointed that nobody recognized Iggy Azalea, but that's okay. I know I'm old. What should we do now?
Multiply by 21.
Multiply by 21. True enough. Multiply everything by 21. Least common denominator. When we multiply this one by 21, 3 goes into 21 how many times?
7.
7 times. 7 times negative 7 is what?
1.
7 times negative 7 is what? No, 7 plus negative 7 is 0, but 7 times negative 7 is 7 times 7 is negative, right? So it's 14, but negative. I'm glad we're participating now, though. Good job, team. Way to go. Way to go. It's the same thing. We got 7 left over to multiply here. So 7 times negative 16 is what? Y'all should have calculators. That should be a thing that you have right now. If not, I know you have a phone because you don't leave home without it. So you can do at least that good, right?
I don't have either on me right now.
You what?
I don't have either on me.
Sounds like a you problem today, right? Sketchy. No, negative 112. Your ocarina of time ate your calculator, huh? Is that what you're telling me?
Yeah.
Yeah. Well, then you need to get on your little ocarina and play a summoning tune and make it happen. Now, when we go 21 into this, 7 goes into 21 how many times? 3 times. So 3 times x is what? 3x. Wow. And 3 times 32 is what? 96. Now what?
Then you're going to add 112.
Sure, why not? All that sounds grand. Add 112. Oops, I left off a plus. And subtract 3x. What's negative 14x minus 3x?
Negative 17x.
Negative 17x equals, what is 96 plus 112? 208. Now what? Divide by negative 17. So what does x equal? Did you punch it in your calculator? We did something wrong, apparently, because that's definitely not what the answer key says.
Oh, I think it's because 7 times, you did 14 instead of 49 for 7 times 7.
Oh yeah, I did. Somehow I wrote 14. Why did I do that? Nobody knows. 7 times, yeah, I don't know what I did. Wait. 7 times 7. I did 7 plus 7. That's crazy. Why did I do that? Because it took so long for y'all to get an answer. I'm blaming y'all. Okay, try again. This is also 49. What's that now? 208 divided by negative 49 is definitely not 52. That's not right. Oh my gosh. Thank you. This problem is a disaster, and we're not even doing a 3x3 system. That's crazy. 4. No, it's not. Negative 4. We did it. Now what? Not all of them. Either one of these two, because we're doing the AB intersection, right? So plug it into B. Sure, why not? So plugging it in up there. Y equals negative 4 over 7 plus 32 sevenths. What's negative 4 sevenths plus 32 sevenths? 28 sevenths, which reduces to 4. So the intersection between these is negative 4, 4. And then we do again, which I think after grading our quizzes, we could probably use the practice. So let's go ahead and do it. So doing these two systems, do the BC, this is the AB. AB. Probably should make it an ordered pair. That's going to be confusing. Let's do the BC. So what do we do now? Substitute one of them in for the other one. Substitute all of this in for y right there, right? X over 7 plus 32 sevenths equals 15x minus 40.
Could you multiply everything by 7?
We could. Why not? Let's do it. Let's kill those fractions. No big deal. Multiply by 7. On this side, the 7s are just going to go away, right? Just going to disappear. 7 goes into 7 one time. What is 15x times 7? 105x. Sounds reasonable. What's 7 times negative 40?
Negative 280.
Negative 280. Now what?
Subtract 32 and subtract 1
No, that's not right. 312, right? Somebody sanity check my brain, which is apparently broken today. 280 plus 32.
Maybe 104x.
104, right?
Why would it be 104? Oh, because you subtract. Y'all sanity check the one I'm asking you to sanity check, not the one I actually got wrong. Calm down. 280 plus 32. Great. Now what? That's what I get for doing steps in my head. What's 312 divided by 104? 3. Great. Now what?
Now substitute back in.
Yeah, which one you want to put it in?
The one with they're both the same.
I'd do the one without any fractions, but I mean, you do you, boo. I'm gonna plug it into C. Y equals 15 times 3 minus 40. 3 times 15 is 45, minus 40 is 5. So the intersection of these is 3, 5, right? Now we got to find the intersection of these. And then we'll have a triangle. So let's do A and C. A and C. So we're going to substitute this for y right there, right? So we've got negative 7/3 x minus 16/3 equals 15x minus 40. We could multiply everything times 3 and kill the fraction. Sure, why not? So we've got negative 7x minus 16 equals 45 minus 120. Sound good? Oh, I made a mistake. 105x.
Oh no.
It is 45. 45 is correct. But what did I do wrong? I didn't put the x. That's true. Subtract 45x on both sides. We end up with negative 52x. We add 16 on both sides. We end up with negative 104. Does that sound right? We almost did that division over here. Part of it was the same. So negative 104 divided by negative 52x is going to be what? No, it's not going to be 4 because this is not it. I don't think it's 3 either. It is 2. X equals 2. I'm going to substitute it back into this one. Y equals 15 times 2 minus 40. 15 times 2 is 30 minus 40 is negative 10. True enough. It even matches. So the corner between here is 2, negative 10. So if you were asked to graph it, which you technically weren't, I don't know why they gave a graph, but if you were asked to graph it, you could stick all those things in there and then you could shade correctly and Bob's your uncle, you're done. But on this problem, as well as like problem 18, 20, and 22, you would have to do all this shenanigans because it wants the numbers and you can't really get that precisely from solving by graphing. Make sense? What other questions do we have, kids?
Can we do 10?
Sure. We can do 10. Where did my eraser go? I didn't write that. Oh, yeah, it is. You're right. You're so smart. You have eyeballs.
Oh, this one should be fun.
You just forgot what it was until just now.
I tried
Yeah, I
to
see.
do it, and I just couldn't.
Number 10. Oh yeah, this one's actually easy. It just looks weird.
Yeah, it's fine.
Yeah.
Great. Number 10. Y is greater than or equal to, or equal to 0. And y is less than x. Somebody's saying words. What are they saying? Let's see. Calculus session went, oh, I don't have enough students to teach calculus. I wish I did, but not enough people sign up for it because I'm doing high school stuff. And so by the time they get there, they end up taking dual credit or something instead of doing calculus. If I could get a full class of calculus, I would teach calculus, but I don't have enough. So pre-calculus happens after this class. But calculus, I don't get to teach, unfortunately. But that's all right. All right. What does the line y equals 0 look like? It's just a horizontal line at the origin. So he's a line that goes bloop, 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 bloop. Except it's filled in. Because of the equals, right? So that's that guy. A line y equals x, what does he look like? Yeah, he has a y-intercept at 0, right? Because there's no b out here. His slope is 1, so we count up 1 over 1, put a dot. Up 1 over 1 again, and we put a dot. And then it's a dotted line, right? Because it's not equal to. Easy peasy. Now we got to figure out where we're shading, right? It's a tricky bit. So we're shading above this one, so that would be up here. And we're shading below this one. So above this one and below this one would be this pie piece right here. This one right there. Okay. Stop doing that. No. Okay. What other questions from this lesson do we have? 16. Did you try it? Good. Good. We can't be looking at words and being like, oh, nope, 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 nope. Okay. Well, you shouldn't do that either, because then how will you know what part of your thinking was incorrect, right? Okay. Don't be afraid. It's like homework. It's good. It's okay. Jane's band wants to spend no more than 575 buckaroos recording their first album. The studio charges at least $35 per hour to record. Graph a system of inequalities to represent this situation. Then list 3 possible solutions. So I like these kind of problems because you have to kind of think about what's going on in order to solve them, really. In a lot of ways, they're simpler than some of these other things, really. Right? So it's almost easier in a way to start doing the graph, kind of. Right? So first of all, what quadrants do we need? Do we need all 4 quadrants? We just need quadrant 1. Why do we just need quadrant 1? Because there's no negatives, hopefully, right? They don't want to, well, somebody's not paying them to take guitars or whatever, right? That's probably not going to happen. That'd be cool. Maybe they're very famous, what is happening? There you go. But that's not implied by this situation, right? So we just need, I don't know why I started so high up. Let's try again. We just need quadrant numero uno, right? Easy peasy, lemon squeezy. There he is. Let's also go ahead and label our axes, because that can be useful for us kind of thinking about what's going on. So what is the x-axis in this particular situation? Hours, yeah. Now, the y-axis, the dependent would be the y-axis, right? And then the doll hairs in this axis, right? Easy peasy. So, they want to spend no more than $575. So what is that line going to look like? It's just going to be flat at $576, right? Because that's their cap. So that equation, what would the equation for that line look like? Not equals.
Y is less than or equal to.
It's 576, right? Yeah. Easy peasy. There's 576. How do I know? Because I'm going to label it. Now it is.
It's 575.
Great. That's what I said. Then we do a nice, pretty solid line up here. Boom. Boom, boom. Shake the room. Great. Now we need to figure out the other equation, right? What does the other equation say? The studio charges at least $35 per hour to record, so sometimes more, which is the shading bit, right? So $35 per hour. Is that the slope or the y-intercept? It's the slope. How do I know? No. It's only one number. 35. Yeah, because per hour, yeah? So that's the slope. So what would the equation of that line be?
Y is greater than or equal to 30
35, right?
Yeah, 35 over 1.
35x. Yeah, 35 over, I mean, yes, if you want to put it over 1, you could. It's slope, but yeah. Easy peasy. So the y-intercept is at 0. So up 35, that's about 35, why not? We can pretend like it's a logarithmic scale. Over 1, so like that, except we'll say 1 is this. That sounds good. 1 hour, 2 hours. So right there. I say this often enough, and hopefully somebody's listening to me, because it's a useful thought to put into your brain. You can make graphs look like whatever the heck you want to make graphs look like. And you should consider that when somebody in the news or in politics is showing you a graph. Look at the graph and look at the axes and what they're counting by and whether it's even logarithmic or whatever. Because if you turn something logarithmic, you can turn an exponential graph into something that just looks like this. And this is much scarier looking than this. Or better looking, right? If we're talking about money, right? Whatever. So you can make graphs look like whatever you want to make graphs look like, because that's how math goes. And the useful application of that, right, is we get a good picture of what we're representing, whatever situation we're representing. The not so great thing with that is somebody can try to manipulate your feelings by making a scary or pretty looking graph. My favorite one recently was where the lady was trying to put up a poll in Congress or whatever. It's like, this is a poll, and some Congressman's like, Madam Congresswoman, that adds up to 125%. This is clearly a fake poll. Whatever you're doing. And then she's still trying, I don't know. I don't know whether she was just like, I don't know. She's still trying to be like, but this is the numbers that we got from this reputable place. But no, that's not mathing, lady. Sorry.
Why would it be greater than 35?
Because it says they charge at least that much. So they might charge them more. And so for that last part, you would just pick 3 points that go in here, right? So like 2 hours and $100 or whatever, right? Something like that.
70.
What?
70.
Sure, yeah, whatever. I mean, you could pick, as long as it's in this region, you'd just write down random numbers.
Okay.
What other questions do we have from this lesson? Number 4? Yes. Did you try it? Good. The most Kala can spend on hot dogs. Oh, there's more words. Let's double check. We need a moderator. Oh, look. Hey, I've seen you before. Hello. Came to say hi since right now I'm watching the new Tron movie. Tell the class I wish them luck. I'm pretty sure that he told me his name was pronounced Safe. So Safe says good luck.
Oh, okay, thank you.
Okay, I think that's how he said his name was pronounced. Anyway, I don't know. Anyway, number 4. The most Kala can spend on hot dogs and buns for her cookout is 35 buckaroos. The package of 10 hot dogs costs $3.50. A package of buns costs $2.50 and contains 8 buns. She needs to buy at least 40 hot dogs. Excuse me, needing my hair over here. She needs to buy at least 40 hot dogs and 40 buns. All right, there's all kinds of things happening in this problem. We need to graph the region that shows how many packages of each item she can purchase, and then give an example of 3 different purchases she can make. Oh, that's funny. Let's see. Hold on. How many packages of each item she can purchase? I'm gonna look at the key and see if my brain is braining right, because I don't even think we need the dollars. I don't think that's even necessary for this problem. Let's see. Oh yeah, so it doesn't really. So this is a poorly written question, really. This is, yeah, because at least 40 buns, at least 4. Okay, so this is kind of a poorly written question because according to the answer key, they do want the graph of like the money on there. So we'll do both. And yeah, okay, great. So she's got to buy. How many of you? I guess it is. No, I guess that is what it says. It's just confusing me as much as it's confusing you. So we need to know we need to know a region of this. She could buy these options, right? She can't actually buy those options because she can't buy half a package. But you know, we're doing the pure math picture, right? Easy peasy. All right. So the first bit is fairly straightforward. First, let's see. What does it say about the numbers she's going to buy? She needs to buy at least 40 hot dogs and at least 40 buns, right? So she's got to have at least. So we're gonna graph hot dogs on the x-axis, HD buns, and what's the other one? No, I don't know. Hot dogs and buns. That's what we're saying, right? Right? Great. We got this. Hot dogs and buns. Hot dogs to buns. Easy peasy. Yes? So, how many hot dogs does she need to buy? If she needs at least 40 and they come in 10 in a pack. She's at least 4. Yeah, at least 4. Right? Right? So she's going to have to get at least this. So we're going to have a line that's here, right? She's going to buy at least 4 of those. This is counting by ones. Right? Buns, how many is she going to have to buy of that if she needs at least 40 and they come in 8 in a pack? 5, because division, that's right. 2, at least, right? She could have more. 1, 2, 3, 4, 5. This is 5. Got to put a line here. We know that ultimately when we get finished and we start doing shading, we're going to shade above this and to the right of that, right? It's going to have to be out there somewhere. But she's only got 35 bucks, right? And they cost money, so she's not infinite, right? She didn't somehow make infinite money hacks, right?
It's a triangle.
It is going to be a triangle, that's true. We need our other equation. So let's go back to the data that we're given and figure out what the equation is going to be. So it says that she's got 35 bucks. So she's got to spend less than or equal to 35, right? We just got to figure out what's over here, right? This problem in the Algebra 1 class, or one of them, they call these weighted average problems, which I think is a stupid name because they're not all weighted average, but that's basically what we're doing. Anyway, packages of hot dogs costs $3.50, right? Package of buns costs $2.50. So if we take $3.50 times the number of hot dogs and $2.50 times the number of buns, and we keep that less than 35, we'll be good to go. Sound reasonable? Now, the way we graphed it, we put hot dogs as the independent variable and buns as the dependent variable. So we need to solve this for B in order to graph it, right? So to solve that for B, what should we do? Subtract the 3.5h, yes. Minus 3.5h. What we do to one side, we got to do to the other side, right? Right. So we got 2.5b is less than or equal to negative 3.5h plus 35. Then what would we do? Divide 2.5 on both sides. Sounds good. Are you still with us? Oh, okay. Don't do that. It's dangerous. Divide by 2.5. Divide by 2.5. Divide by 2.5. B is less than or equal to negative 7/5. 7/5 H.
14. Wait. Minus 14. Yes.
Plus 14. So then we would graph that. Go up 14, 5, 6, 7, 8, 9, 14, up there somewhere, right? And then go down 7 over 5, down 7 over 5, and we end up with whatever the line's going to look like. We could, if we had some graph paper and all the things, we could do a better job, but it's going to be something kind of like this, coming down from the sky, right? Having all the things, and then it's got to be shaded right there. So she can buy any combination of that. So she goes to the store, and there's got 6 buns, but less hot dogs for whatever reason, then she's got options to get what she needs, right? It'd be the same. It'd be the same because it doesn't say which one. There's no way to really tell which one's independent and dependent on this particular problem, which is rare in circumstances, but yeah, this one technically doesn't really have a, this is definitely dependent, this is definitely independent.
Well, we gotta put into the factor of tax.
We gotta put into the factor of tax. We gotta, yeah, so if we wanted a perfect model, we would want to include tax. But that would be taken care of in this equation, right? So you do whatever the tax would be, you would change the 250 to, like here, it'd be 250 times 1.0825, and whatever that is would be times the thing. But yeah, that would take care of it. And then your model would in fact be perfect, but we don't care about that on this problem. But that would be how you would do it if you were going to care. And you needed a precision model that was that precise. This is more teaching you how to do a thing. Why don't we take a quiz? Or do we have other questions? Okay, let's, wait. It's just like 6.
It's just like 6.
Yeah, where you'd have to solve all these little systems, and it'd be fractionally annoying, but not necessarily difficult. All right, let's do quiz 3-2, numbers 7, hello, and 9, and that's it. Ready, set, go.